A 7¼ inch gauge Sweet William steam locomotive. This one is part 54, the missing episode. Fitting the tank reinforcement blocks in place, drilling the holes underneath the tank for the balancing pipe, and time to look at the water pump plumbing. This episode should have been episode 55, and the previous episode should have been episode 54, but I got it wrong. I edit a video almost every day, and sometimes it is quite confusing. I can't really put this down to a senior moment, it's just incompetence. Not incontinence, incompetence. But anyway, nevertheless, I can show you what I did for episode 55, which is now episode 54. I'm countersinking the holes underneath the tank to accept the 4BA countersunk bolts that arrived in the post this morning. I'm pleased to say and fairly smug that all of the bolt holes lined up with the holes that I drilled in the tank. Even though I did the job in a really strange way, I am aware of this and I'm definitely not going mad. Neither am I. I wanted to show a different method of doing a job like this. And in any case it was successful. Now it's time to fit the blocks permanently into place. I'm using some sealant on the blocks to prevent any water leaks. Because once the middle part is fitted to the tank, anything inside the tank is going to be difficult to get to without removing quite a lot of 5BA countersunk bolts. In this clip, I'm applying more than a generous amount of sealant, after which I level it off with my finger and clean around the edge. You can see it oozing into the parts where the bolts are going to be. This is okay, I don't think I'm going to get any leaks from this area once all these bolts are in place. These blocks will become a permanent fitting inside this tank. I don't think I will ever need to remove them, and if I did, the best way to do it would probably end up being drilling out the bolts, which is not a major job anyway. That's one side fitted, now time to move across to the other side. I'm removing the bottom two hexagon bolts that were temporary fittings. This allows me to countersink the two lower holes. I loosely fit the bolts in the bottom two holes and countersink the top two, after which I apply the sealant to the block to fit the bolts for real. For some reason it was more difficult to fit this side, mainly because of the position and the fact that I'm right-handed. I enlisted the help of a large spring clamp which made the job easier. And in this part of the clip I'm using a needle file to align the hole for the other bolt. With the top two countersunk bolts screwed into position, it was a very easy job to fit the two lower ones. The more I watch this clip though, I really think I should have done the job in a different way. The simplest method is to drill the holes in the brass first and then mark the positions onto the blocks, then drill the holes in the blocks and thread them. But all's well that ends well. This is an extremely useful model engineering workshop tool. It's a Proxon angle grinder fitted with a flapper wheel, and it's great for doing jobs like this. I'm doing it fairly roughly to show you how it works. I'm just cleaning around the bolt heads to make sure that they are all flush with the tank. I'm finishing off the job with some emery cloth, and the job is looking good. Time to move on to the other side. Same principle, clean across the parts where the heads are, using the flapper wheel on the Proxon angle grinder once again, and after this, exactly as before, I clean up the general area using a piece of emery cloth. Now when I run my hand over this area, I cannot feel the positions of the bolts, which is always a good sign. The scratches are a good thing, they will form a perfect key for the paint. In fact, at some stage I will be rubbing down this entire tank, so that with a bit of luck the paint does actually stick to the brass. Brass is quite a difficult metal to paint. I'm actually pleased with the end result. These are very smooth, and when the tank sits onto the mountings, nothing will be in the way. One job I'm not looking forward to is fitting the centre part. I need to use sealant throughout, and quite a lot of 5BA countersunk bolts. Although I seldom use it, because I need some flexibility, I'm going to use some silicone sealant to seal the tank. The next job is to drill two holes for the balancing pipe. Yes, I can see that the scribe line is a tiny bit away from the initial mark, but that's because the initial mark was in the wrong place. I need to drill two holes, one at each side, so I'm marking a position which is 6 inches from the end and 1 3/4 inch from the inside edge of the tank. I do this at both sides in exactly the same place. I thought it was a good idea to test my eyesight, so here I'm bending a piece of 3/8 inch diameter copper pipe, which was quite difficult to bend. It's a good job I'm strong. I bent one end of it, then I turned it round and bent the other end. Initially, I held the piece of copper tube against the tank, and then I estimated where the bends needed to be. This is not a precision component, so there is some room for error, but I tried to bend the pipe so it lined up with the marks on the tank, and indeed it did. It was out at each side by a 1/16, and in this case that is nothing to worry about. You can see in this clip that the bends on the pipe are fairly near. Look at this. Not bad at all. Literally a 1/16 at each side, maybe out. This saddle tank has to provide a water feed for the hand pump at the left-hand side and the axle pump underneath the engine. The water feed to the injector will be from the tank that's part of the riding truck. On the tank, using a felt tip pen, I slightly corrected the positions of the holes. And what I'm doing here is using my Proxon motor tool to initially drill the holes, followed by drilling the holes a 1/4 inch diameter using a 1/4 inch diameter drill bit. Drilling sheet metal when it's unsupported can be problematic. This 1/4 inch drill bit goes through okay and gives quite a nice round hole. If you look carefully, you will see that the hole is to the left of the scribed line. And now I'm going to repeat the process on this side. And here you can see that the hole is just slightly to the right of the scribed line. This 1/4 inch diameter twist drill bit is quite sharp and goes through very quickly. I need this hole to end up 7/16 inch in diameter, and here I'm using a 7/16 twist drill. This is not a good idea. The hole doesn't look too good. It looks almost hexagonal. For drilling holes in sheet metal, it's a much better idea to use tools that are designed for the purpose, like these hole cutters in a set that I have. They were not expensive and they work very well indeed. I'm using the original hole as a pilot, but when you're using these hole cutters, be careful because they can wander slightly. These stepped hole cutters give you various options on sizes, and this size is 7/16 inch in diameter, confirmed by using this part of a globe valve that broke. Now it's time to move to the other side. The principle is exactly the same. The broken part of the globe valve goes through this hole too. These hole cutters do cut quite clean holes, but they still need deburring, and I'm doing this using a piece of emery cloth. Now the specially bent piece of 3/8 pipe fits perfectly in these holes, right in the centre of both of them. This is going to be the balancing pipe, but I may end up modifying the centre of it as a take-off point for the water pumps. I will also need to fit a valve to drain the tank. I've seen a lot of terrible plumbing on saddle tanks, and the thing is, the plumbing is very visible, so it needs to look a little bit slick in my opinion, not just randomly fitted like this is at the moment. I need to sit and think about the piping layout before I make any decisions. That's it for now. Stay safe, stay healthy. Thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.